All attendees are in listen-only mode.
Hello everyone, thank you for attending today's webcast titled Integrated CAM with Full 5-Axis, Autodesk InventorHSM Professional, presented by Matthew Nichols, Solutions Engineer with Hagerman & Company. We also have Tad Whitchurch, Director of CAD CAM Training and Support with Hagerman, on the line to assist with your questions. This presentation is being broadcasted in a listen-only mode. You can ask questions by typing them into the questions section of the GoToWebinar control panel on the side of your screen, and Tad will address those throughout the presentation. At the end of the broadcast, when you exit GoToWebinar, you'll be prompted to fill out a short 3-question survey. We ask that you take a few moments to provide us with your feedback. Also, all attendees will receive a certificate of attendance and a link to the recording of this presentation. Matthew, whenever you're ready, you may begin.
All right, thank you, Berdina. Again, thank you all for joining us today for this event. Before we go into our demo today, I'd like to give a quick overview of the company behind the product, its contribution to the CAM industry, and a brief overview of product's approach to manufacturing machining with integrated CAM. Autodesk is a world leader in 3D design, engineering, and manufacturing software. Since the introduction of AutoCAD more than 25 years ago, Autodesk has been setting the standard for design and engineering. The Autodesk portfolio is the broadest and deepest in the industry. With Autodesk, you have access to leading-edge technology, regardless of industry or application. There are 10 million plus Autodesk customers at more than 800,000 companies around the world. We believe in helping to streamline workflows and leveraging a digital prototyping experience, a single data file from concept through manufacturing. Now let's focus on the last part of that workflow, manufacturing. So Autodesk, by the end of this year, will have spent or invested more than $250 million in the CAM industry. Since acquiring HSM Works over 3 years ago, Autodesk has been able to enable more users to have access to the best-in-class integrated CAM. Based upon our high-speed machining kernel, which is what HSM stands for, Autodesk has released 3 product choices for our customers. HSM Works, a fully integrated solution for SolidWorks, InventorHSM, a fully integrated solution for Inventor, and the first cloud solution, CAM 360, which you can do CAD and CAM with. So why choose an integrated CAM solution? According to the July 2014 SIM data report, the fastest growing segment in CAM software solutions is integrated CAM. Integrated CAM leverages the existing investments a company makes in their CAD tools. Because of this, typical 8-step machining process, and of course the 16-step machining process where an ECO is involved, is greatly reduced when the CAD data is leveraged. Reducing the steps to updating CAD data, regenerating and validating the toolpaths, and posting your code, allowing the NC programmer and design engineers to take control of their NC programming process. Many downstream benefits include ETO automation, streamlining communications, true work group collaboration, ECO accuracy, and faster turnaround time. There are a lot of players in the integrated CAM space, and Autodesk focused on just one, HSM Works. The founders of HSM Works shared the Autodesk Innovator vision. When you consider major advancements in the CAM industry, you will find an HSM Works founder behind them, including the birth of adaptive clearing, which became the basis at which high-speed machining, or HSM, was built upon, and a lot of first-to-market options, both technological advancements like distributed CAM and the first-ever CAD/CAM cloud option, and business benefits such as a free post library, open API, and flexible purchasing options to meet the nuances of each type of company. So with that, there are 3 different flavors to HSM. We have HSM Express, which is full 2.5-axis milling, HSM Standard, which includes the 2.5-axis milling, plus 3D milling, 4-axis, 3+2 milling. And then HSM Professional, which includes everything in standards plus multi-axis milling. Each package offers customers flexibility in pricing and a number of nice extras not typically found in legacy CAM systems, including an open API, access to more than 75 post-processors, adaptive clearing, and tool libraries. The product levels are not modularized. They also allow you to leverage integrated CAM regardless of your budget and machining needs. And in the case of our standard and professional versions, you will receive a copy of either Fusion 360 or Inventor CAD. These are a couple of examples of companies that currently use our workflow and the success that they've had. So now with that, we'll go ahead and move into our demonstration. So first what we're going to do is look at the 2.5 axis side of the program, just briefly. So you'll see here I've got a part with multiple pockets and some drilling operations. So what I want to do is first I'm going to come in and create a stock setup. So here I'll select my model. And then what I want to do is, one thing you'll notice is that they've made it really easy to be able to define your stock. There's multiple different stock options, and for this one, I'm going to create a from solid stock. So what I can do is go back into my model, which I've created multiple solid bodies, and pick my stock solid from there. And then once I've defined my stock point for my work offset, I'm ready to go. So what I'm going to start off with is a simple face milling operation. So I'm going to click face mill, go into my tool library, click my 2-inch face mill, hit select, and hit OK. And you notice how quick it generated that face mill operation. Next, what I want to do is I'm going to come in and clear out these pockets. So I'm going to go into my 2D adaptive, again go into my tool library, pick my 3/16" flat mill, select it, and then what I'm going to do is I'm just going to select on the pockets, or I can even select on the contour. Click OK, and I've already cleared out the pocket. So now, say I want to go in and clear out the rest of the material around the outside. So one thing you'll notice is if I make changes to feeds and speeds in here, say I come in here and make 7,000 RPM instead of 5,000, that modification won't automatically update into my library. So if I wanted to keep that change in my next operation, I can right-click on here and click Duplicate. This way it'll quickly make a duplicate operation of what I just created, to where all I have to do is go into my Geometry tab, clear it out, and pick the outside of my part. So now, in a pretty quick 2 operations, I've been able to rough out the inside of the pockets and rough the outside of my part. So now, let's say I want to come in and do my finishing passes. Again, I can right-click on my operation, derive the operation into a 2D pocket. Again, notice my feeds and speeds stayed along with the tool and my geometry selection. So here what I would do is go into my Passes tab, which is what defines all the cutting parameters, and remove stock to leave. Again, I can right-click on my outside pocket, or outside contour, create derived operation, and this time I'm going to do 2D contour, and notice there's stock delete was already turned off, so here all I have to do is hit OK. So let's say I go in. Now I want to do my contour around the edges with the chamfer bit. I'll pick 2D contour, go into my tool library, and pick my chamfer bit. Select all my chamfers. And now you'll notice one thing that Autodesk has done is they don't want to clutter your user interface. So notice never before have I had this chamfer option until I add it on you to be able to go through all the options. They just pick the ones that are viable for that situation. So here what I'm going to do is I'm going to put an offset of 0.05 in. Go ahead and click OK, and there's Toolpaths. So what I want to do is I want to use that same chamfer bit, and I'm going to spot drill these holes. So I'm going to go into drill, pick my chamfer bit, and all I'm going to do is pick the conical face of one and select same diameter. So it goes in and quickly finds all other faces that are similar, so I don't have to go in and pick all of them. And next we're going to go ahead and pre-drill the hole for the tap. Again, I'll pick my drill bit, select the small diameter. I can do select same diameter. And one thing that they want to do is notice the cut isn't going all the way to the top. But I want to make sure that my bit's going to clear all the material. So what I'm going to do is pick auto merge hole segments so that it finds everything, so I don't have to worry about losing bits in the process of machining this. And there we go. So again, what I can do is go into my tool library, pick my tab, geometry, select same, auto merge, and there we go. So basically, we've done that in just a few minutes. We've already machined that whole part. So now what I want to go ahead and do is I'm going to do a simulation to verify that I've actually cleaned everything out. So I'm going to turn on my stock. And I'm going to go ahead and simulate. Now one thing that's available in the HSM Standard and HSM Pro is the ability to do a part comparison, where I'd be able to turn on and see the material that I have left to machine from what I'm wanting to machine to. One thing also that you can do is you can make transparent your tools and holders. Now that this is done on the machining part, I can go ahead and do show comparison. So now you'll see everything in the dark blue is material that's still left on the stock comparative to what I'm trying to machine. Now another thing that you can do is, say you have a pallet situation where I have multiple of these parts sitting out. There's different ways that you can do patterning operations. One way that I can do that is I can select all my toolpaths, add a new pattern, and I can create either linear patterns, a circular pattern, or so what I'm going to do is I'm going to pick this edge. I'm going to say I want to offset it 5. and say I want to do 3 instances. I'm going to say OK. So now you'll see that if I was to do a simulation on this as well, the stock's only going to show up for 1. But as you can watch, it does the simulation now on the side too. And if I show Toolpaths, then you'd be able to see it. So there's multiple ways of getting things done that are either the same, or even if they're different, you could pattern with those operations. Okay, so that's the basics of our 2.5 axis milling. Now let's go ahead and go into the 3 axis milling. Again here, I've got a die piece. I've already got my stock set up. So I'm going to go ahead and start putting in Toolpaths. So what I'm going to do here is I'm going to go to my 3D adaptive milling. I'm going to select the tool, pick a 3/8 inch bull nose. And with this one, all I'm going to do is I'm going to hit OK. And what it's going to find is all the open space that it needs to machine out. So there, within a few seconds, it's already developed a toolpath for me. So say I want to go in and I want to do another pass to clean out a little bit more. Because if you'll notice, there's going to be quite a bit of material left from this mill operation, which we'll see whenever I turn on the comparison. The 3/16 inch tab, and now with my rest machining turned on, go from preview. Okay. So as that one's going, I can go ahead and start a new horizontal one. And I'm going to machine the top of this part, or the top of this feature. So with the same bull nose, I'm going to change my height tab to be just below the top of that part. So that it won't see the top. I'm going to click OK. And notice now I've got a horizontal toolpath on the top of that feature. Now I could also go in, instead of changing my height tab, I could also just pick the surface, and then that would do the same. It's already calculated for that second adaptive clearing that we've done. Now what I want to do is I'm going to go in and start doing my finishing passes. So what I want to start with is a parallel move. And for this one I'm going to do a 1/4 inch ball. And then what you'll see over here is I've got the option to do slope now. So I'm going to do my slope. And I'm going to change my to slope 35 degrees. So now with that, notice it's gotten the top of the part, which I'm not wanting, but now I've also got my contour down in here. So let's go in and edit this real quick. If I go back to my geometry tab, you'll notice it's a void touch surface. I can click the top of the surfaces that I don't want to touch. And let's say I want to change my step over. So I've got a 0.125 step over. Let's say I want to do a 0.05. And so now you'll see it's missing the top, and the top of that surface. It's turned 45 degrees, and I've got a finer step over than what I originally had. So next I'm going to go into the scallop with the same 1/4 inch ball. Again, I'm going to do a slope. This time, instead of changing the to slope, I'm going to change my from slope to 30 degrees. This way I have a 5-degree overlap, so I make sure I don't miss anything. Okay, so you'll notice that I got the outside of the part. Now, the way to get rid of that is tool containment to center. That way it goes to the center of the tool goes to the edge of the part. It doesn't go past. And finish that again. B. And the last thing I'm going to do is, if I go ahead and simulate all this, that will be in here and here and around in this area. So what we're going to do with that will be a pencil command so that we can finish those radiuses off and finish the part. So notice the dark areas and the radiuses. Okay. So with that, I'm going to go into my pencil operation, pick my 16th-inch ball mill, and I'm just going to go ahead and hit OK and see what I get. So I've got the smaller radiuses, but I'm missing the larger radiuses. So let's go in and edit Toolpaths. So I want to come in here and change my over thickness 0.125 so I can find the larger radiuses. And I'm going to change my step over to 0.02, and I'm going to limit the number of step overs to 4 so that I don't go too crazy. So then you'll see once that gets done calculating that I've gotten all my radiuses, got 4 step overs, and it's a really fine finish. So that was a pretty quick way and pretty easy way of being able to mill out that die in a little number of steps. So next thing I want to do is I kind of want to show some of the other capabilities that 3-axis milling has. So you saw earlier I used the parallel command to do some of the finishing on different slopes. So here's a way you can see parallel going over the whole part. And then here I'm containing it to a certain pocket. So by selecting the geometry around the pocket, it limits it to that area. I can also limit it by selecting certain geometry. And then the outside of the part, it's going to contain it to just that area. And then also if I do this, I'm defining my top and bottom height, so I'm containing it to a certain section of the part as well. Now if you have a part like this one, where it's got cuts through the outside of the wall, but you're not wanting it to mill that way in the first, as this one does, so you notice whenever it goes in to mill this part, it cuts through the outside of the wall. Say I wasn't wanting to do that whenever I first cut that part. I just want to hog out the inside and then come back and do a cut to be able to finish the outside. If I go in, notice I've got kind of a transparent body on the outside that's the same size as the part, same features as what I want to be machined from, so that it's not actually machining the outside. So then by doing that, I'm able to rough out the inside of it without disturbing the wall structure. Another one is check surfaces. So say you got a part with the hole through it, like as this one does, and you see this parallel, it goes down into the hole. The way to be able to get around that, or to be able to go over that, is to be able to create a surface that just covers the top of that pocket so that it recognizes that. And by doing that, I can select it as geometry that I want it to include so that it mills that out without going into that pocket, so I can drill that out later. And then again, you can, if you don't want to do it with the surfaces so that it just goes up to it and doesn't actually touch it at all. Or I can tell it just to touch those surfaces by itself, and it doesn't even touch the rest of the part by turning on touch. And notice I've got those two pockets selected. Okay. Now let's go ahead and look at some of the capabilities that have been added with the HSM Professional version. So one thing you'll notice, I've got my part in the wall. So I've got my morph spiral, which machines that contour. And I've got my actual contour that I'm trying to use to machine the outside of this wall, or this diameter of the stock. So what you'll notice is I've got that face selected as to cut. But what I've got here is I've got this shaft and holder option turned on. So if I want to make sure that I'm not hitting my shaft of the tool or the holder on the stock or the model of the part, I can turn this on. I have multiple different options to be able to determine what I'm doing. I can do, as you can see in the pull-up, I can do a pull away, which will pull the tool away from the model so that it doesn't hit. I can do a trimmed option, which limits the length of the tool path depending on where the shaft of the tool or the holder would hit it. Fail on collision, does what it says. If it detects a collision with the shaft or the holder, it automatically fails that tool path. So for this one, I've got it turned to trim. I've got my shaft clearance 0.04 and my holder clearance 0.2. Now what you'll notice is with that trimmed option, I've only gone halfway down, 3/4 of the way down that part, but I need to get the rest of this. So if I do a contour command, the new thing with the HSM Pro is the ability to have this multi-axis tilting. Now with that multi-axis tilting turned on and your shaft and holder options turned on, just notice I've still got it turned on and I've still got the same parameters. I'm able to tell it if you hit the stock or the model, tilt so that you can clear it. So I've got my maximum tilt angle to 90 degrees. So what you'll see is I'm able now to go all the way down to the bottom of the part where I need to be able to get a smooth finish on the part. Now next we're going to go in and look at some of the multi-axis milling operations. So with HSM Pro, you get this panel on your ribbon with swarf and multi-axis contour. So I've got this part set up. I've done my adaptive clearing to get most of the material off. So now what I want to do is I want to go in and I want to create some finishing passes on it. Now with swarf, there's multiple different options again. It's not just one tool path. There's multiple different settings in there that allow you to do things you need to do. And the one great thing about how HSM works is whenever you hover over any kind of option within your toolpath, it gives you a pop-up, and it does a very good job on explaining what you're actually getting. So you'll notice this one I've got set up as a single pass. I've come in here, I pick my surface that I want to actually machine. It's driving by contours, and my selection mode is faces. Again, there's different ways you can do it. I can do either contours or surfaces. I can do, on my selection mode, I can either do by faces, contour pairs, or manually. And so that's a swarf, a single pass. Now if I go into the swarf spiral, this is what you would get. And so with this one, I've got my my step down set, so it knows how far to step down as it goes down. And then again, I've picked it by this face. So this one, minimizing axial, and this just minimizes the amount that it goes into that curvature, as you can tell by the toolpath. And then I've got my morph move, and then on this one, I'm using an actual 5-degree taper tool. So if I was to go in and simulate this one, again, I'm doing my adaptive clearing to remove the excess material to get it down to where I can do my finishing passes. So again, while doing this, there's 3 different tabs that you can do within the simulation. The Info tab gives you all the XYZ positioning. It gives you the operation information. And it also gives you the information about the toolpath, and it gives you an idea of what the machining time is. I'll do this one. So notice with this one, I've got a longer time. I'm showing 2 operations and 1 tool change. So one of the things we didn't show was if I do a from bottom operation, you'll notice that the tool path actually does the swarf around the tool. And then again, if I come in, say I change this from from top. And so what you'll notice is the blue lines are all my cutting moves, but I've got this little green line, which is my ramping operation down into where I'm starting at. So I'm coming in here, ramping down to the bottom, and then it's going to be cutting to the top. And one thing I was going to show was the ability of 3+2. So here's an example of how you can do 3+2 machining on a, I would say, a very complicated part, but not have too many operations, and how easy it can be by controlling where you're machining by sketches. So let's go in here. And then in my tool library, this one I've got a 7/15" ball mill. But you'll notice in my geometry, I've actually created a sketch part to define the area that I'm wanting to actually machine. So what you can see here by this outline, I've got it there. I've got a 15-degree plane that I've created as well for it to orient the tool off of, which you can see by the work ordinance axis. And then one thing you'll notice is the ability to create your custom libraries the way you need to. So if you're an ex-Mastercam user or what have you, and you have these Mastercam libraries to transfer over and afraid it's not going to work, you can create new libraries by importing. I can create values, so by an Excel sheet, and then I can import Mastercam tools and holder libraries. So that way you're not losing any information and lots of work that you've done in the past by creating those. Plus, you'll notice that all these tools are stored within the parts. And this is one great thing, that if you use a tool in a part, you make a modification. So like on this one, I made a modification to the spindle speed on this adaptive. You'll notice whenever on the tool, it shows 5,000 RPM in it, but whenever I'm on the actual operation, it shows that change that I've made to it. So it's not modifying the actual tool in your library, it's just modifying it for that actual operation. To do this, almost 6 hours later, you'd have your own Ironman helmet. And one thing I'll mention on the tool library also, that it doesn't matter the type of units you're doing. The units are all derived off the units of the part or the assembly file that you're using. So if you have inch, it'll go by inch. If you have metric, it'll be metric. Also within the tool, if you go into the cutting tab, you can change your parameters for that as well in here. Then I'm going to go ahead and show. So one of the great things is if you create setup sheets for your machinist to have it, that HTML file that you can print out. Here you're going to get your work coordinate system, the stock dimensions of your part. You get the number of operations, tools, and then you get the information about each tool that's being used within that process. Another way is if I go into my post library, I can also post out using this as the setup sheet to Excel. So this way it'll actually post that setup sheet into an Excel file where you have 3 tabs that would be able to be printed out and used by the machinist. The only major difference between that and the HTML is you don't get the images. And then you'll also notice that with the program, even the free version, there's this whole library of posts that comes standard with it, which is a very vast library. Let's say I'm going to post on a hospital. Is probably one of the best ones out there. There's so many different things that you can do within the editor that make it so easy to use and make it so easy for you as the user. One feature that I absolutely love is this backplot window. Because here I can run through my lines of tooling, and if I see something I want to make a change on, I can pause it in motion, and I see that I'm at line 77. I can change a variable in here if I want to, and then just keep going. So it makes it easy to do on-the-fly changes if you absolutely have to. Another great thing is if I come in here, I can do comparison of files. So say you have one NC file that you posted, say the machinist made a change at the machine. You can bring them back both in here and compare them and see what the differences were, so that you can make sure you have an up-to-date post file. And then I also have the ability to post straight to a machine from here. A couple other things. I can renumber. I can tell it to block skip if there's a certain area that I don't want it to do. So there's many other things in here that make life simpler for you and your machinist. Okay. With that. So that's our demo for today on that. Simulation. Is there any questions?
While we're waiting on questions to come, oh, sorry, I'm getting some feedback. I'm going to go ahead and jump in and just thank everyone for attending today's webcast. We are going to hold the line open for a few more moments for your questions, so if you have those, go ahead and type them in. If you think of a question after we close this session, you can just reply to the email you got from GoToMeeting, and we'll get those questions routed to either Tad or to Matthew. As a reminder, you'll be receiving an email containing a link to the recording of the presentation, and if you could take a few moments to complete the short survey that will appear on your screen when we close the session, we would greatly appreciate it. So thank you for attending today's webcast, and have a great day.